So far in this course, we've been using an NPC sensor on each NPC to detect the nearby hostiles or friendlies. We're using physics.overlapSphere to detect all the NPCs in the vicinity of an NPC. And then we filter out the results. And we do this in the NPC sensor component of each NPC in our scene. So this in itself is not very performant. It's generally faster to have a list of NPCs that we can loop through. So we're going to create an NPC Manager component that has a list of all the NPCs in our scene. So I suspect that the change in performance will be minimal. However, the simple fact that we'll have a list is going to make it easier to optimize our code in the future. So if we have a list, we can implement some form of multitasking. We can have multiple threads working on different parts of the list. We can use the Unity job system. And in general, the whole ECS dots approach of Unity is geared towards having lists of objects. And for the component on each object, in our case, the NPC sensor, they would work more like data containers. So we're going to move in that direction. So our purpose right now is not exactly to increase performance, but to organize our code in such a way that if you want to add performance enhancements later, you can. So not only are we going to add an NPC manager, we're also going to implement a grid system. So our game world will be split in a grid made of tiles. On each tile, we'll have the list of the NPCs on that tile. And later on, we can add a list of items to each tile. Using this grid system will make it very easy to get the NPCs around a given position. And we're going to use that for detection instead of the physics methods. And later on, we can use the same grid system to get the list of items around an NPC. So for example, if an NPC has an empty magazine, or if their weapon is depleted in some way, they can look for another item or for ammunition. Right now, given the number of NPCs and the number of colliders in our scene, the performance is not that bad, but once we start adding items and if we increase the number of NPCs, then the hit on performance will be very apparent. With a grid system, it's very simple and very performant to get access to a tile given the parameters of that tile. So for example, if we want the tile at 2, 1, this is going to be it. So this is the tile 2, 1. And given the size of each tile in meters, we can convert from the world position, for example, the position of an NPC, to the position on the grid by simply dividing the position of the NPC or the position of an item by the tile size. Let's start by creating an NPC Manager script. Let's go to Scripts, Game Managers, and I'm going to right-click, Create, C# script, and call my script NPC Manager. In the NPC Manager script, we're going to have a list of NPCs. So we're going to define a list of NPCs and we're going to serialize it so we can view it in the inspector. We will make our NPC Manager a singleton. So let's define a private static NPC Manager instance and then a public static NPC Manager instance. When trying to get the instance, we'll check if it's null. If it's null, we're going to call find object of type NPC Manager. If it's still null, we're going to print an error on the console saying that the NPC Manager is missing in the scene, and then we're going to return the instance. So I'm going to put this code in the singleton region. That way we keep our class organized. Let's add a couple of methods, add NPC and remove NPC. To add and remove an NPC from our list, you know what, for this list, let's call it NPC list instead of NPCs. Okay, now we need to go to our NPC script. Let's go to Scripts, NPC, and then NPC. And I'm going to scroll down all the way down to the Unity methods. Let's add an onEnable method. In it, we're going to call npcmanager.instance.addNPC with this reference. Then let's add an onDisable method where we're going to remove the NPC. Okay, so now we have an NPC Manager that has a list of all the NPCs in our scene. Let's go back to our scene. So in the Game Manager's object, I'm going to right-click and add a new empty object. Let's call it NPC Manager. In here, I'm going to add our NPC Manager script. So here we have the list of NPCs. So I'm going to run the game. Let's make sure that this NPC list contains all the NPCs in our scene. Okay, so I'm running the game. And as you can see, we have 84 entries in our NPC list. So this is the player, and we have a list of civilians and all the sentries in the scene. So we have 84 NPCs in total. When we go out of the play mode, we get these error messages on the console saying that the NPC Manager is missing. This happens because the onDisable method is called on our NPCs. So what we can do to fix this is to simply suppress all the errors using a try catch. So we're going to encapsulate this line between try and catch. So the onDisable method is useful in case you want to remove some NPCs from the scene. So perhaps when your NPCs have died, you want to remove them after 5 seconds or 10 seconds, for example. So once you destroy the object, the onDisable method will be called. But when we get out of the play mode, it doesn't matter if we call this method or not because we're ending the game. So we're simply going to suppress all the error messages here. Okay, so this is the first step. Now let's move on to implementing some functionality from our NPC sensor into the NPC Manager. And to keep things organized, I'm going to split the NPC Manager into multiple files. So we're going to declare the class as partial, and in the same folder, I'm going to create a new script. Let's call it npcmanager.vision. Okay, so we're going to remove the mono behavior and then write partial. I'm going to have a coroutine called CR Vision back to the NPC Manager main file. We're going to add some Unity methods. So let's have a region. Let's have a start method. And here I'm going to start my CR Vision coroutine. Okay, let's go back to our Vision coroutine. In our NPC sensor, we have a scan rate. We will no longer need this. Back to our NPC Manager.Vision. We're going to define a vision scan rate, which is a float. And in our CR Vision coroutine, we're going to define a scan wait time variable, which is going to be of type wait for seconds. And we're going to add an infinite loop. So while true, and at the end of that loop, we're going to yield return scan wait time, and we're going to loop through the list of NPCs with a for each loop. So for each NPC, we're going to do some things and then yield return null, which will skip the current frame. So we're going to process all the NPCs in our list every scan wait time, but we'll only process one NPC in each frame, which will greatly reduce the hit on performance. In our current scene, we have 84 NPCs, including the player. So roughly we'll need 1.5 seconds to go through all the NPCs in our scene. We can modify this to, for example, process 2 NPCs at a time or 3 NPCs in each frame, but I'm going to keep it this way. I'm back to the NPC sensor script. So we're going to need to call the scan method on our NPC sensor. Let's go to the Unity methods. We're going to comment out the start coroutine. Let's copy it first. So we're not going to use a coroutine, we're just going to use a normal start method, and we're going to comment out the coroutine version. We're going to clear the detection list and remove all the rest. So we're going to not do this, and instead I'm going to cut this code and remove the while loop, and instead we're going to have a public void update sensor where we're going to have the scan method, the update detected entries method, the update herein method, and we're going to sort the detection list. So back to our NPC Manager.Vision, we're going to call NPC Sensor.update sensor, and we're going to have our yield return null only when we find an NPC sensor. We can remove the yield return null at the end. It will never be called. Okay, so I'm just going to check our NPC sensor one last time. We still have some code in the update method. Let's rename the update method to sensor update, and let's make it public, and we can remove the start coroutine, and here instead of update sensor we can rename this method to sensor scan. That way we can have the scanning methods which are slower here and the faster code in sensor update. Back to NPC Manager.Vision, let's add a vision update method, and for each NPC in our NPC list we're going to call npc.sensor update. Let's go to our NPC Manager's main file. Here we're going to add an update method in the Unity methods region, and in this method we're going to call vision update. Back to NPC Manager.Vision, I'm going to add a yield return null at the start of the coroutine, just so we can skip the first frame. And also here we're using a for each to loop through the list of NPCs over multiple frames. Now, if the list of NPC changes in a given frame, for example, when spawning a new NPC, we may run into some errors. So we're going to replace the for each loop with a for loop. Let's also add an int here. Let's call it NPC scanned, which will keep track of the number of NPCs that have been scanned. So if we have scanned the sensor of the NPC, we're going to increase the NPC scanned count. If NPC scanned is equal to 5, we're going to yield return null, and we're going to reset NPC scanned to 0. This will allow us to scan 5 NPCs per iteration. When stopping the game, we no longer get the error message that the NPC Manager is missing, but we are getting our debug log error. So I'm simply going to comment this out. So in case we don't have an NPC Manager, we will get a null reference exception anyway. Okay, let's test our code. So now our goal is to just see if everything is working like it did before. So I'm going to switch to the red team and I'm going to see if the NPCs are able to spot me. Okay, so they are able to spot me and engage me in combat, which means that the NPC sensor is working exactly like it did before. So except now, all the scanning is managed by our NPC Manager. Okay, now we're going to add a grid made of tiles. So I'm in the NPC sensor script. We mainly want to replace the scan method here. Let's go to the scan method. In an earlier episode where we introduced the NPC sensor, we were using physics.overlapSphere to capture all colliders around the NPC. And then in a later episode, we optimized the code by using physics overlap sphere non-alloc. This saved us a little bit of performance by not generating garbage like overlap sphere. But now we're going to use a grid instead. Let's go inside the game managers folder. Let's create a new folder. Let's call it grid system. Let's create a new class called world grid, and let's create another class called world tile. This one is not going to inherit from mono behavior. Our grid will have a 2-dimensional array of world tiles. So let's add a few properties to our tile. Let's add a vector to int grid position, which we can get publicly but only set privately. Let's create a constructor that takes the grid position as parameter. This way we force the world grid to assign a grid position every time it creates a new tile. Let's add an NPC list, which is going to be a hash set of NPCs. I'm using a hash set here instead of a list because a hash set does not allow us to have a duplicate element in the hash set as opposed to the list where we can have duplicate elements. Now let's go to our world grid class. So we want this class to be a singleton. So we're going to define a public static instance, and we're going to get this instance from NPC Manager, since the NPC Manager is already a singleton, and we'll have a reference to the world grid. So we're going to go into the NPC Manager and we're going to add a reference to the grid. Let's define a vector to int size, which is going to be the number of tiles on the x-axis and the number of tiles on the z-axis. Then we're going to define a 2-dimensional array that will hold our tiles. We need to initialize this array at some point. So I'm going to define an internal method, initialize grid internal, where we're going to initialize our tiles array, and we're going to give it the size x and size y. Then we're going to loop through x from 0 to size x and y from 0 to size y. And for each tile, we're going to initialize it using the world tile constructor, and we're going to give it the grid position. So we're going to use this method inside of the NPC Manager. So here in the NPC Manager in the singleton region, when we get the instance for the first time, we're going to get the grid and call initialize grid internal. You know what? In our NPC Manager, let's add an awake method. We're going to check if instance is null and then print an error message. In fact, this message will never be printed. Our goal is to just initialize the instance. So by getting instance here, we're going to indeed call the getter of the instance property. And one last detail, if you're using Unity 6, the find object of type will be deprecated, and instead you'll have to use find first object of type. So let's use it. So instead of find object of type, we're going to use find first object by type. Okay, back to our world grid script. Let's draw some gizmos to visualize the world grid. First, we need to convert from the coordinates of the grid to the coordinates of the world. And in order to do that, we need to define how big is a tile in world coordinates. So let's define a float tile size, which is going to be the size of each tile in world coordinates. So this is basically the size in meters, because one unity unit is considered to be 1 meter in size. I added tooltips to remind ourselves what each variable is. So the tile size is how big is a tile in meters, and the size is the size of the grid in tiles along the X and Z axis. Let's define a method, grid to world, which will convert a grid position, which is a vector to int, to a vector tree. So here we have two choices. We can either return the origin of the tile, which is the bottom left corner of the tile. Of course, I'm talking along the X and Z axis, or we can return the center of the tile. So here I have a boolean at center, which is set to false by default, and this will determine if we're going to return the position of the center of the tile or the position of its origin point, which is, as I said, the bottom left position along the X and Z axis. Our X coordinate will be grid position.x multiplied by tile size, and our Z coordinate will be grid position.y multiplied by tile size. If at center is true, we're going to add half the tile size to both the X and Z coordinates. Then we're going to return a new vector tree with X, 0, and Z, plus the transform of our grid object. You can remove this, transform that position, if you want your grid to be in absolute coordinates. So the 0 on the grid will be the 0 in the world. But in my case, I want the grid to be customizable. So if we move the world grid object itself, that would be the position of the center of the grid. And this will allow you to customize the grid to fit your level. Okay, so we have a grid to world. Now let's work on world to grid. So the world to grid method will return a vector to int, and will take a world position as parameter. First, we need to convert the world position to a local position by subtracting transform that position. We're going to obtain the X coordinate by dividing the X component of local position by tile size and using mathf floor to int. And we're going to do the same thing for the Y coordinates. We're going to divide the Z coordinate of local position by tile size and then use mathf floor to int. And then we're going to return a new vector to int with X and Y as parameters. Now let's define a getTile method, which is going to take a grid position and return a world tile reference. But first, let's define a method called isGridPositionValid, which is going to test if the position is inside of the grid. It will return true if the X coordinate is between 0 and size.x, and the Y coordinate is between 0 and size.y, and we're going to use this method inside of getTile. So if the grid position is valid, we're going to return the tile at X and Y, and if not, we're going to return null. Okay, now let's draw some gizmos to visualize the grid. So in the variables, let's create a new header. Let's add a boolean draw gizmos. Let's set it to false by default. We're also going to define the height of the grid. Let's set it to 1, and the color of the grid, let's set it to green. Okay, so let's define the onDrawGizmos method. If drawGizmos is false, we're going to return. Then we're going to set the gizmos color to our gizmo color. And we're going to loop through the list of tiles using 2 for loops for X and Y. Then we're going to use gizmos.drawWireCube to draw a box at center and size. And we're going to define these variables. So each wire cube will have a size of tile size on X and Z and gizmo height on the Y axis. As for the center, we're going to use the grid to world method, and we're going to give it our grid position and set the @center parameter to true. And then we're going to add the size.y divided by 2 on the Y coordinate of the center. Now let's go back to the Unity editor. So in the game managers, I'm going to create a new empty. I'm going to call it world grid, and I'm going to add the world grid here. I'm going to go into the NPC Manager and set the reference to the world grid. Okay, back to the world grid. So the grid is here. We're going to enable the gizmos. Okay, so this is our grid. It seems that the world origin is here. So I'm going to move it so that it contains all the geometry of the level. So let's disable the fog in the scene view. Okay, I'm going to maximize this. I'm going to move the grid here, something like this. And then let's increase the size so that it contains the whole geometry of the level. Let's pick a size on X equal to 60 or 62. Yeah, let's choose 65. And then on the y-axis, let's choose like 50 or let's say 60. We can also increase the size of each tile. So if these tiles are too small, yeah, let's increase the size of the tiles. Let's choose a tile size of 10. Yeah, this should do it. So it highly depends on the type of game that you're making. In our case, a size of 10 or even bigger will work just fine. If we increase the tile size, we'll have to reduce the number of tiles. So let's choose like 40 tiles or even 30. Yeah, let's say 35 on the X, and perhaps on the Y we could have like 40 or even 35. Yeah. Okay. So the grid contains all the geometry in our level. Okay, let's go to our NPC script. And here I'm going to define the grid position. So let's add it here. So this will be the position of this NPC on the grid. And that's all we need to do. Let's go to our NPC Manager. And here we're going to update the position of the NPCs. Let's go to the update method. Let's call an update grid positions method. We're going to define it here. We're going to loop through the list of NPCs. For each NPC, we're going to compute the grid position using grid roll to grid with the NPC's position. If the grid position is different from NPC.grid position, it means that the NPC has moved. We need to handle the case when the NPC has just been created. So we can do it in two ways. We can either update the tile where the NPC is at in the add NPC method, or we can do something else. In the NPC, we can set the grid position to a value that is invalid, like for example, -1, but we're not going to do it. This is not very reliable. If you change the grid position in the inspector, the code might not work, and we don't want that. So instead, back in the NPC Manager, when we add a new NPC, we're going to initialize the grid position of the NPC. Then we're going to get the tile on which the NPC is using grid.getTile, and we're going to give it npc.gridPosition. If tile is not null, we're going to add the NPC to the list of the NPCs on the tile. In case we don't find the tile, we're going to print an error message, NPC is outside of the grid, and we're going to display the grid position. Okay, let's go back to our update grid positions method. So here the old tile and the new tile should be defined. So we're going to remove the NPC from the list of NPCs in the old tile, and we're going to add it to the list of NPCs on the new tile. Back to the editor. Here I have the NPC script of my player's character. So here we have the grid position set to 0, by default. I'm going to run the game and we're going to see if this position is updated. So my position currently is at tile 17,9. Let's enable the gizmos on the game view and let's go to our grid. So in Game Managers, World Grid, let's enable the gizmos. Okay, so here I can see the tiles. So right now I'm at 17,9. I'm going to move around. Okay, I think there is a problem. My grid position doesn't seem to update. Yeah, so in the update grid positions method, I forgot to set the position on the NPC. So here we need to say npc.gridPosition and set it to the grid pos variable. So I simply forgot to set the new grid position, but now it should work. Okay, so now I'm at 17. Now I'm at 16. 9, 15, 9, and if I move along the z-axis, you can see that the grid position is increasing in the y-axis. So now I'm at 15, 15. Okay, now in the NPC sensor, we're going to replace the scan method. When scanning for nearby NPCs, we're using a range. So this is the range variable that we define on the sensor. We need to convert this range to the number of tiles that we need to scan. And instead of this method, we're going to define another method. Let's call it update NPCs in range. And we're going to give it a hash set of NPCs. We're going to be calling this method multiple times before we proceed to the rest of the scanning code. So in sensor sensor scan, we're going to remove the call to the scan method and we're going to copy this code. So here we are looping through the list of colliders. Instead of this, we're simply going to loop through the list of NPCs. So I'm going to do a for each NPC in list. We're not going to need this. So let's rename this variable to other NPC. Okay, I'm going to remove this line. So let's check the code again. So valid will be true if other NPC is not null, if other NPC is different from our own NPC, and if other NPC is alive. So if the detection entry doesn't contain the other NPC, and if the other NPC is within the FOV and we can raycast to it, then we add a new detection entry with this NPC. So the code seems to be okay. We're going to comment out the scan method, so we don't need it anymore. And let's go back to our NPC Manager.vision in the CR vision coroutine. So here, if NPC sensor is not null and if NPC sensor is enabled, we're going to call npc.sensor.sensor scan. Let's do this in a method. So let's define a method here. Let's call it scan nearby NPCs. We're going to call it here in the coroutine, scan nearby NPCs, and we're going to give it our NPC, and we're going to move this code in here. So we're going to call npc.sensor.sensor scan. But before doing this, we're going to call npc.sensor.update NPCs in range. Now we're going to get the tiles around the NPC. We're going to define an integer scan radius. This is going to be the radius that we're going to scan in the number of tiles. So I'm going to use mathf floor to int with npc.sensor.range divided by grid tile size. And we're going to add one tile. So I don't have access to the range. So let's go back to the NPC sensor. So the range variable is a private variable here. Let's add a public range that's going to return our range variable. So let's imagine that the range is lower than the tile size. So in this case, this floor to int will return 0. But let's say the NPC is at the edge of the tile. We cannot simply get the NPCs inside of the tile because the NPC may be close to other NPCs on nearby tiles. That's why we add 1. So we're going to loop through the nearby tiles. We're going to start X from minus scan radius to scan radius, and Y from minus scan radius to scan radius as well. The tile position that we're going to check is going to be equal to npc.gridPosition plus vector2int x, y. And here we're going to call our update NPCs in range method. So we're going to need the tile. So we're going to get the tile at tile position, but we need to make sure that it is not null because the NPC may be at the edge of the world. And in this case, we may get some invalid tiles. So we're going to call npc.sensor.update NPCs in range, and we're going to give it our NPC list. Okay, let's go back to NPC sensor. So here we no longer need the scan rate. So we no longer need the scan mask. I'm going to right click on it, find all references. So indeed, we do not have any references to this variable. So I'm going to comment it out, but we're going to keep the raycast mask because we're still using raycast. And finally, we no longer need the colliders buffer. So I'm going to comment this out. Okay, now we're going to test this code. Okay, so I'm going to check if the NPCs are still engaging me in combat. So they are able to see me without needing to use the physics.overlap sphere, which is really good. So we should save a lot of performance. Okay, so our code is working, and game development is like this. Sometimes you do a lot of work, but without any change in the visible results. But now we have a working world grid that we can improve on. And the specific improvements that I'm thinking of is to add items. So if we have items lying on the ground, for example, a gun or ammunition, our NPCs will be able to see them, and the code to do this will be very fast, much faster than looping through all the list of items in the world or by using physics. So we have this foundation in place, and we are good to go to add more interesting things. If you like this video and the content on this channel, then you can head over to the Ko-fi page of the channel. For as little as $5 a month, you can keep this channel going strong and help me produce more content and deliver much more value to you guys. So form the phalanx, defend the line, and thank you so much for your support.